on to the practice problems. Go ahead and try these questions out with us.
Here we go. All right, so we're just doing like step 1.
Mm-hmm.
Gosh, I'm like stressed out. Okay, so we do that, and
You're good so far. That's right.
okay. Okay, so now we have to balance this out. So
Good.
we have to multiply this technically by 2, so it becomes CuCl2.
Good, correct.
Okay. And then we're gonna add the next thing. And I'm trying to do this the way that you were, so like. So then, sodium nitrate. Nitrate.
Yep. Periodic table can't save you now. Yeah.
I know. The periodic table is not saving me now.
Nitrate was NO3 with a -1 charge.
Oh my gosh. And
It's like dust off those flashcards.
I know.
Bring them back.
NO3 with a negative what?
-1 charge. Mm-hmm.
Oh, great. Okay, so this is just NaNO3.
Correct.
Okay. And then
Good.
so now we do. I'm like really slow. Sorry.
You're fine.
Okay, so now we're doing copper to nitrate. So it's gonna be. We said that's that, and then the nitrate is the NO3 with a -1.
Correct.
Okay, so we have to multiply that by 2, which means it becomes CuNO3 2, right?
Correct. Good. 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 Yeah.
Okay. Just had to dust off the that. Okay. Next, sodium chloride.
Yep.
So just NaCl.
Yes.
Okay.
Cool.
All right. So now we just do like the normal steps, right, from last week?
Yeah, from balancing, correct, yeah.
Yeah. Okay. I'm gonna move this up.
Yeah. Now I'd say it's like the easier part, right? Balancing wasn't too bad.
This is freshest in my memory, so.
Good.
Okay, so we have 1 copper, 2 chlorines, 1 of those and 1 of those, and then we have 1 of these. Okay.
Good.
So I guess we can just start from the top
Yeah.
because we don't have oxygen or hydrogen. Okay.
Exactly.
So copper is good. For this chlorine, we're gonna put a 2 over. Wait, we need to get this to a 2, so we're gonna put a 2 here.
Good.
That makes that a 2, and that a 2, and that stays the same.
Perfect.
And then over here, sodium, we need to put a 2 in front of that. Oh wow, how nice is this? Okay, so then,
Yeah, this one's nice.
so then it becomes a and 2. Yeah, okay, I was making sure I was seeing that right. I'm like, wow, that was really that easy. Okay, so
Yeah.
now we're good, right?
Exactly. I felt bad for how much I was giving you, so I made it easier.
For how much you traumatized me earlier.
I was like, we'll do the difficult one together.
Just go ahead and bring all this back before spring break.
Sorry.
Oh my gosh. Okay, so I'll rewrite it, I guess. Right, because we're going to need to, like, refer to this.
Yeah, we are. Yeah. But hey, you'll be ready for your final. We'll make sure of that.
By the time you're done with me. Oh man, I can't fit this.
Okay. By the time I'm done with you, you'll have an A in this class.
I really hope so.
I think you already do.
So far, so good.
Yeah.
I know. Right now I do, but I'm scared because, you know, there's an exam and then a final standing between me and keeping my A.
Yeah. I'm not worried.
I am. Okay, I'm just going to copy this because I know we're going to need it. Oh my gosh.
Cool.
All right, moving on. So should I just paste this?
Yes.
Because I need it, right?
Yes.
Okay. What on earth?
Oh, yeah.
Okay.
That always happens to me. Oh, hi.
You're just so fast about this. Let me erase the line. Please hold. Here we go. Okay. There we go. All right. Cool. So, all right. This is the hard part. So, we start out with what we are given, which is here.
Yes.
I know that in our little thing. So.
Mm-hmm.
Oh,
let's actually put what it is. Yeah.
Copper too. Wait, so do you just write like it like that?
Yeah, exactly.
Okay.
Cool.
Okay. Oh my gosh. Please hold. There we go. Okay. So then we have to do. Oh wait, let me. We're gonna go from grams to moles.
Good.
And then moles to grams or something.
Yes, that's right.
Okay.
It's like gram, mole, really mole, gram.
Gram, mole, mole, gram. Yeah, that's what I have written down. So molar mass, mole to mole ratio, and then molar mass.
Yes.
So
everyone is just going to memorize that. They're all just going to be like gram, mole, mole, gram.
Gram, mole, mole, gram.
I know. I just know it.
Okay. You should see what I wrote on my paper for the percent. Do you have a percent yield in here? Like
yes,
for me to do?
I do.
Okay,
yeah.
Good. I'll wait for that.
Okay, we'll wait for that moment.
Okay.
Cool.
Here we go. So, I know we have to do. I just can't remember like what this all means, but I know I have to find the molar mass now.
Yes, but let's take a step back and just make sure we understand what we're doing instead of it just being memory.
I don't.
Yeah.
Okay.
So this is asking us to find the limiting reactant, right? And it gave us the mass of each reactant. And then it's telling us how much sodium chloride, so there's your hint as to which product to choose to go to, can be formed. So we're going to take each reactant, the grams of the reactant, and then go to the grams of our product, which they're specifically telling us to go to sodium chloride.
So you're saying use this?
Yes.
Okay.
Yeah, our goal right now is to find the grams of sodium chloride from each reactant. Mm-hmm. Go for it.
So, here we go. So
hang on.
I literally don't know what I'm doing. Let me just be honest with you for a second. So I'm gonna. I know that I have to like be able to. Okay, cool.
Yeah. Let's just write it out.
So I have to cross things out. All right.
Yes, you have to cross things out. We're going from grams of copper chloride. And how about let's actually just write it on top, like the plan. So grams of copper chloride, arrow, and then arrow moles of copper chloride. And then we're going to go to moles of our product, so NaCl.
Oh, this is helpful. Okay, now I can see what's going on.
And then grams of NaCl, which is the goal. That's what we're trying to find right now.
Okay, the bowl. All right.
Yeah. Go for it.
So now we're first going to moles. So I'll put the moles up here.
Correct.
So 1 mole.
Yes, of copper chloride. Good. What goes on bottom?
Oh, the molar mass
Exactly.
that we have to find. Okay.
Yes.
Here we go. All right, so copper is so tiny. Okay, 63 point. I really need to get a bigger one of these. 546, and then chloride is.
Good.
Okay, so 134. I write the whole thing out?
Yes, you do. You don't round.
Okay. So there's that, and this is going to be our grams of.
Perfect.
Right? All right, cool. So now we are here in our step. So now we're going from the moles of that to the moles of sodium chloride.
Good. And what do we use now? Like, where do we find the moles?
Oh, yeah. Okay. So we use, the 2, right?
The balance equation, correct. The coefficients in the balance equation. Good. So, but hold on. That's for the moles of NaCl. So remember, we always want to put, so that's on top. Yeah, exactly.
Okay. So I put 2 moles.
Correct.
Of NaCl.
Yes. And what's on bottom?
And
how many moles of copper chloride do we have in our balanced equation? And if there's no coefficient there, assume it's 1.
Oh, okay. I remember you saying that in the video.
Cool. And let's just make sure to put 1 mole. 1 mole of. Yeah, you're good. Cool. And then we know to do that, it's on the bottom because it cancels out, right? We always want to have the 2 across from each other so they can cancel. And then now you're at the last step.
Okay, so the last step is to go from the moles of NaCl to grams. So, so now I have to do the molar mass of the sodium chloride. So 22.990 plus 35. Okay. And that's the grams, so...
Yes.
But how do I know where I'm supposed to... Oh, we want to end with that.
We want to end with grams, so whatever we want to end with is on top.
Okay, so I put it down here. So...
Hold on, so you put it up there. You want grams, right? It's going to be on top. Another key thing to see is moles of NaCl has to now be across from the other one to cancel, right? So that's why moles of NaCl will be on the bottom, and grams is what we're trying to get, which has to be on top.
Okay, I'm just confused because there's moles on the top and the bottom, like, right here.
Correct.
So normally, which is, would I go...
Oh, keep going.
Like, I normally go moles is here, so then I would put moles down here. But for this one, I can't use that guide, right?
You can though, because why don't you cancel out units just so you can see what I'm talking about? So we'd cancel out grams. Then that. Good. What are we left with?
Oh, okay, I see. So that's how we know. Yeah. Okay.
Correct.
I was like, what? All right, so we put our number up here. It's been a while since I've had to do this. Like back when we were converting liters to something.
Way back.
Oh
way back.
When. All right, so this is grams of NaCl.
Mm-hmm.
And now, that's it. Now we have to do our math.
It is true, but just make sure that it is per every 1 mole of NaCl, right? Because molar mass is grams per mole. Yeah. Perfect. Just so if we were to cancel the units, it would give us grams. Good.
Yes. There we go. And then we end with that. Okay. So here we go. So 15 times... I don't have a graphing calculator, so I'm going to write this down.
It's fine.
Oh, it's just 1. Okay.
But good, yeah, it would have been if there was a number actually on the bottom. Good. I'm glad you're getting used to that, though.
I'm over here spending so much time, like, multiplying it by 1. This is my life. Okay. 175. Okay, so now because we have, it would be 2 sig figs, right? Because...
So let's look at how many sig figs did we start off with? It was 15.00.
Oh, those zeros count, so...
Yes, they do. 4 sig figs,
Let me review
yes.
my sig fig rules, too. Oh, oops. Okay, 13.04, because it's actually 39, but we're rounding that.
Cool.
And this is grams of NaCl.
Perfect. Okay, so...
Oh my gosh, now we have to do it for the other one.
We have to do this again. I know. We have to do this again for the second reactant. So what I like to do is, like we could erase, but I like to just put that copper 2 chloride and then kind of like equals or produces 13.04 grams of NaCl just to kind of keep it simplified so you know to look at this at the end.
Okay, I see what you're saying. So, like, do this.
Yeah. And then we'll do this all over.
Can I just add a page so that way I can keep my work for the first part?
That's totally fine, yeah.
Okay? All right.
Yeah.
Cool. All right, so I just need this. Oh, I should have grabbed the whole thing in the question. Okay.
You can't just duplicate the page?
Oh, can I do that?
Yeah.
Where do you see that?
Copy page on the very top.
Oh, and then add a new page?
Yeah. And then it should let you paste page. Yeah.
Oh, so do I click current template or squared paper?
Current template. Page? You just put paste page, actually. Yeah.
Oh. Oh my gosh. Okay, I'm sorry. I do not know, obviously, how this works.
It's fine. Mine's a little bit different, but it's basically the same thing. It's the same app, just different versions.
Yeah. Okay. So here we go. All right. Let's do it again. I'm so slow at this. So.
Okay, you're just learning this.
So now we have to do, so this time we're going to be using this to start.
Correct.
Oh, it's up here.
Good.
Okay. Oh, but first let's write out what I'm going to be doing again. Okay.
Exactly.
So we're going from, because that's helpful. I'm going to look at this. So we're going from grams of NaNO3 to moles of NaNO3, right?
Good.
To moles of the NaCl.
Good, the product, yeah. Grams of reactant, moles of product, grams of product. Mm-hmm.
Oh my gosh. All right, finally. Starting to like make a little bit of sense to me.
And that's fine. The more you do this, the more it's going to click.
Yeah. Okay. So here we go. So we're going from grams to moles. So we need to put our grams down here, which we have to calculate. Good. So we have to do 22.990 plus. This is the most tedious part. Calculate.
It really is.
Alright. Sometimes when I can't find an element, I'm like, okay, who moved that on the periodic table? Could have sworn nitrogen was over there.
It's next to oxygen.
What?
Yeah.
Right. Okay. 15.999 times.
Who moved this?
Like that. Seriously. All right. I think that's literally me. All right. There we go. And this is our grams of. And now we're going to do that for the moles. So is this the one where I have to take the number from the thing, or that's the next one?
That's the next one. When we're doing mole to mole, when we're changing the compound, right? Mole to mole ratio. But yeah, molar mass is always grams and moles.
Okay, so this is taking us now to, so now I just put the 1 mole of it?
Yes.
Right?
Yeah, 1 mole of NaNO3, yeah, correct. And it's always 1 mole for our molar mass, yeah.
Okay.
And then now it's from the balanced, yeah.
Okay, so the mole to mole ratio, okay.
Yes.
So here we are with this. This is our mole to how many moles? So I do this?
Correct.
Oh, but I gotta put
moles, yeah.
And then
hold on, try that again. So not NaCl. If it helps you to cancel out units, please do so.
Oh, wow. Wait, then where did I get that? Oh, I got the 2 from over here this time. Okay.
Yeah. That's why I was like, oh, you're good. Yeah, 2.
I know. All right. That just looked out for me. Okay. So now I'm trying to figure out where we're at in this. So this is our mole to mole. So we went from that. So we do our grams on top of the NaCl now. So let me see what that was. Right? 58.443.
You're still missing the top part of the mole to mole ratio. So we haven't put everything.
I'm skipping.
Yes, don't skip.
Oh, okay. So this is the 2 NaCl.
That's the 2, correct. Moles of NaCl, right. Yes. Just put moles on top. That's fine. Cool. And then now, yes, it's correct. This. Yeah, I agree. Everyone should, really. So now we can use the molar mass of NaCl, which is basically the same thing as the last part that we did. So you're fine to use the same molar mass as previously found.
Okay. I just got to do this so that I can see.
Okay. Yes.
So I'm putting that down here.
Correct.
The 58. Okay.
Hold on. The moles of NaCl will go down there because we're trying to cancel it out. Yeah.
Oh my gosh.
We're trying to get
Why
to
did
grams.
I do that on the other side? I literally just looked at the fact that it was on top.
But it makes sense why it's on top, right?
Yeah, because we're canceling.
Yes. Yeah.
So and that's what we're trying to get to. Like from here has to be down here. Yeah,
exactly. So. Yes.
Okay. So this is grams of NaCl. And then now we put the, what did we do?
1 mole of NaCl. Correct. Oh, wow. So it's always, with molar mass, it's always going to be 1 mole. It's always equal to 1 mole. the number that you find on the periodic table after you add everything up goes with the grams, and it's always 1 mole on either top or bottom. You know, that's based on the units you want to cancel.
Okay, yes. So now I will do my math. Mm-hmm. Whoops. Okay, so we're gonna do 4 again.
Mm-hmm. Good.
Grams of, now we put this now, right?
Hold on. So what was our final result?
Oh, no, we put, we put this and then we put that. Okay, because like over here.
Exactly. Saying what our reactant produced in product. And then we're going to compare it.
Oh, whoops.
Good. Okay.
All right, so now.
What do we do now to find the limiting reactant? What do
we have to look at each of these, and the limiting reactant is going to be this.
Perfect, because it produced the least amount of product. So good, that is our limiting reactant. How much sodium chloride can be formed?
13.04.
Perfect, whatever our limiting reactant produces. Awesome. Okay, now hang on to that number, 13.04 grams. That is our theoretical yield, to then do the next question.
So should I copy that?
Yeah, just make your life easier, yeah. Copy that.
The whole
and then
thing or just the 13? Okay.
The whole thing. Yeah, the whole thing.
Oh, the whole thing, okay.
Oh, sorry. You're good. You're good. You don't have to copy again. It was just the 13.04 grams of NaCl.
Oh.
you already copied it, I think. Yeah.
Okay, here.
You're good. Perfect. Now this is saying how much of the excess reactant is left over. So I'll walk you through the steps again. And this is where we're going to go from. We're going to actually start from the theoretical yield that we have, which was at 13.04. So we're starting with our theoretical yield, and then we're going to make our way to the grams of the excess reactant. So we'll write down the steps again. If we want to do grams of NaCl, we're going to get to then moles of NaCl. Now we're trying to change the compound to the excess reactant, which was, what was our excess reactant? Yes, correct.
NaNO3.
Good. And then lastly, it's going to go to the grams, of our excess reactant. We'll do all that.
Okay, this is definitely making more sense to me now because it is the same process.
Exactly.
I'm starting to see that.
Awesome.
Okay. It's just setting it up kind of gets confusing to me.
Yeah. And that's why I want you to understand it instead of memorizing it.
You're right. Yeah, that would not help me in this instance at all because you have to be able to set it up after that, so it doesn't really matter.
Exactly.
Okay. All right, so we're starting out with our grams, and then we're going to go to the grams for NaCl, so I can just use the number, right?
Yes.
58.443. Did I put it in the right spot this time?
Yes, you did. And I'd say just darken the decimal.
Oh, yeah, true. Okay.
Cool.
So there's that, and then we're going to put our moles on top.
Good. Yep, just one. Awesome. We will need our balanced equation again. If you want to bring that back.
Okay. So now we need it, right? Because we're doing the mole to mole?
Yes.
Okay. So our mole is on the bottom.
Yes, moles of what?
Now we're going to this. So I just put 1 mole.
So not 1, and it's not of that. What I want you to get used to doing is canceling out the units already to help you get to the next one, because I think that's what's tripping us up. Yeah.
Okay.
There you go. So what should be on bottom? Moles of what?
I guess the NaCl.
Exactly. Yeah.
Because that's the only thing.
That's the only option, right? That's all we have to cancel. So yeah, moles of NaCl is on the bottom.
Oh, this is where I'm... Never mind, I'm confused. Okay, so 1 mole of NaCl?
Not 1. This is where we're going back to the balanced equation. Yeah.
You just told me that. I'm sorry. Oh my gosh. Okay. So we use the 2, right?
We use the 2, correct? The coefficient in front. Good.
Okay, so 2 moles of NaCl. I promise I will eventually catch on. And then the grams of...
Not the grams, hold on.
Going.
Where are we going? Yeah. Good.
Oh.
We're trying to get to
moles again.
There you go.
So
we're trying to get the moles.
So we do 2 moles of the NaNO3.
Perfect.
Now we're doing our grams on top.
Perfect. Yes.
Of that, so I can see what it was.
Yes.
That's the 84, right?
Correct.
Okay, 84.987.
Good.
And then that's just
bottom.
over 1 mole.
Yes. Good.
Okay, so cancel the moles.
Mm-hmm.
And that's it. Now I just do my math?
Correct.
Oh my gosh, I thought you were going to say there's something else. I was like, I think I got all the steps. Okay.
No, you're good.
All right. Wow, this is quite a bit to write.
Good. So this is what we used of the excess reactant. It's not telling us our excess. It's just saying this is how much is used for this overall reaction. So now we have to figure out what the excess or the leftover is. Okay. So yeah,
I'm just gonna write that.
Yeah, how much we used. So how much we used up, or I just want you to think this was used.
This was called the excess.
This is the excess.
This isn't the excess.
This is the excess. This is the excess reactant. It's not how much is left over of the excess reactant. That's what we're finding.
Okay, I see what you're saying.
Cool. So the last step is to take the original amount that they gave us in the previous question and subtract it from what we just found, which was how much was used.
So the 18.96 minus that?
So the opposite. 20 minus the 18.96, right? The original amount minus what we used. Because we can't have a negative value.
Oh, so you're talking about what they gave us in the problem?
Yes, correct.
Oh, okay. All right, so. I'm just writing this out for my own purposes for the notes. Okay, so I know that you're probably thinking, wow, why is she putting that in her calculator? You can never be too sure. Before I embarrass myself on camera on national YouTube.
On national YouTube. Yes.
1.04.
That's right. So cool. That is our mass. And then just how we would write it would be 1.04 grams of NaNO3. That would be your final answer. That's how much is left over. And I guess this is national. That's very true. Or it's even international. Crazy.
Yeah.
But cool. So that's our answer for our excess. If you want to write in your notes as well, just putting like where that 20 came from. The 20 is the original amount in the problem minus your the used amount. So that's just something to definitely remember.
So should I label this then from?
Yeah, I'd say just label it. So that's from the original question. And then that 18 was what we found, right? Yeah, exactly.
Okay.
Cool. And then now we finally found our leftover. I'll say our leftover. Perfect. Last one is our percent yield. So insert joke.
So here we go. So, but I made it even better. Okay, so here's what I said. I drew this in my book. This is the yield, right? Like the yield sign. So percent yield is where it's at.
Nice. Times 100. Yes, correct. Good. So it's where it's at times 100. Yes.
All right, percent yield. So what do you think I should grab from the other question?
So let's look at the formula, right? Let's look at the formula and what does the at actually represent?
Oh, that's important.
So what does the A represent?
The actual and the theoretical.
Cool. So from our question previously, did we find either of those? And not that specifically, but I want you to think, not this question specifically.
Yeah,
sorry.
this is the...
Correct. Yeah, that's right. That is the...
Theoretical.
What? Theoretical. Perfect. So we need that. Yeah. And that's the only thing that we're going to have is, using all this, the limiting reactant tells us what the theoretical yield is. Cool. We have the theoretical yield. We are most likely going to be given the actual yield in the question, and then we're asked to find the percent yield. So
whoops, just kidding. That was an accident. Okay, so hold on. So the actual yield.
Mm-hmm.
How do I get that one again?
Let's read the question and see what it's...
Oh, it tells us. It's fun when you listen to what you just said. As soon as I ask a question, then I like replay back what you just said. I'm like, she literally just told me that. Learning is fun. Okay.
Learning is fun. Yes, teaching is fun.
Okay, here we go. So...
Good. And percent yield is where it's at times 100, right?
So now I can just do the thing.
Exactly. Yeah.
I'm like so hard at it sometimes. Okay, whoa. 0.00. So I'm gonna use...
Wait, what? Wait, hold on. What? Do that again.
Wait. What? Okay. Yeah, true. What? All right, don't mind me. See, it's a really good thing that you double check me because this is what I do. I don't even know where that came from.
I think you divided by 100.
Oh, probably. That sounds like something I do.
Cool. How many sig figs exactly? Perfect. And this is a percentage, so we'd put percent.
Woo!
Exactly. That is the percent. Yes. Woo. And okay, I'm going to say that this question is extremely important. And I'm going to say this for everybody. This is the number one question. Limiting reactants is like the number one question, number one topic found on every single final I have ever seen in chemistry 1. Okay, so
there's gonna be like multiple questions on that, you think?
There's gonna at least be one that's gonna be worth a good amount. So I'm just telling you, like on your test, there's probably gonna be multiple limiting reactant questions and stuff like this, like worth a good amount of points. But on your final, I already know that for sure, if you're curious what's on your final, this will be on there.
Okay.
Like this is a favorite, yeah. So that's why I'm like getting this down is so important because you are gonna see it again for your final.
Okay. Yeah, absolutely. And I can tell that this is something that I'm struggling with, so I need to practice it a lot.
Yes. So I definitely think, besides reworking these problems again, I have, I think, a couple of videos on the study plan on limiting reactants and percent yield that will help you with this. So I recommend doing those again. And you have the limiting reactant notes, exactly. So doing that will be important as well. Melissa Lucy is also trying to figure out every single one of these steps. This is new to her as well. And you know what? That's okay. The whole point of this is to practice and for you to understand what's happening in every single step. So try another question out, watch another video because you can do this.